Greetings, hello, welcome. Let's do some more example on nonlinear inequalities. Let's say we're given one first example as uh, solve 2x cubed minus 3x squared minus 32x is less than minus 48. Okay, and the second one would be let's say 3x cubed minus x squared minus 12x plus 4, and everything is greater than 0. So these were our examples, and the question was, well, solve the following nonlinear inequality and sketch. So solve and plot or sketch on your number line, or sketch on the number line. Alright, excuse me, let's get to it. Solution number 1. Now the first thing we need to do is rewrite this in a standard form. So we cannot have a number on the other side of the equals of the inequality sign. So we need to bring this on the other side of the inequality sign. So in other words, we group all the term on one side of the inequality sign. So if we do that, if we move this to the other side, it means the sign will change. 2x cubed as it is minus 3x squared as it is minus 32x plus 48, because it jumped over the sign. So everything this side is greater than 0. Now let's solve the inequality. But then to do this, to solve the inequality, we need to factorize this, and then be able to sketch it on a number line, and then on the number line we'll be able to identify the region with the solution that satisfies this solution. Okay, so we can factorize by grouping. Okay, in this case, all right, let's do that. Okay, we have x squared here and x cubed common to these first two terms. So let's take out x squared multiplied by, okay, let's do that one quickly. 2x cubed divided by x squared. Okay, this one and this one. Okay, 3 minus 2, so that gives me 2x. So right there we have 2x. Minus 3. Alright, what can we do with these ones? Do we have common factors? Of course we do. What are the common factors that are divisible by 32 and 48? Alright, Let's try 16. Let's try 16. It's 32 divided by 16. Okay, 16 there is 1. 16 goes in there 2 times. Is it true? Yes, because 16 plus 16 gives us 6 plus 6, that's 2. Carry 1, 1 plus 1, that's 2, plus 1, that is 3. 32. Okay, what happens if we add another 16? 2 plus 6, that gives us 8. 3 plus 1, that gives us 4. So this tells us that 48 divided by 16 gives you 3. Alright, cool. Excellent. Nice, good stuff. In this case, we would say, alright, let's take out minus 16 as our common factor. So minus 32x divided by 16 minus 32x divided by minus 16 gives us 2x. Okay, minus 16 is 1, minus 16 there it's positive 2, and then carry x, so 2x plus, well, wait a minute, that's not plus. Let's test it out, because we have 48 divided by minus 16. Obviously a positive divided by a minus gives us a negative. And then 48 divided by 16, we found that out to be 3. Alright, so we have our 3 right there. We have our minus 3 as the solution for this one, minus 3. So x squared, open bracket, 2x minus 3 minus 16, open bracket, 2x minus 3 is all greater than 0. So that's the condition. Okay, let's see if we can take this a step further. A step further would look at the first term and this second term, because they are separated by a minus, by a subtraction sign. So the first term and the second term, do they have common factors? Absolutely, yes they do. 2x minus 3 and 2x minus 3 are similar factors of these terms. So we factor those out. 2x minus 3 multiplied by, what is left here if we take out 2x minus 3? Well, x squared is left. X squared minus 16 is greater than 0. Okay, how did we get minus 16 and x squared on their own? This is what we did. We performed the following operations. We said x squared minus, open bracket, 2x minus 3 is our first term. We divided it by the common factor, which was 2x minus 3. So from here, 2x minus 3 and 2x minus 3 cancel out, and then we have x squared left just on its own. And we did the same here for 16. Minus 16 divided, okay, let's just correct that. We had minus 16, 2x minus 3 divided by 2x minus 3. 2x minus 3 cancel out, and then you just have minus 16 as your solution. That's how we got there. Alright, cool. Okay, let me just erase that. Alright. Excuse me. So now let's solve this. Solving this, we just divide by one of these. Okay, now I'm going to teach you something nice. Whenever you have two products, or two, these are not terms, whenever you have expressions or a difference of two squares, or whenever you have factors multiplying each other like this, you can be able to equate each of those factors to 0 and solve for x. This is what I'm saying. Whenever you have factors like this, you can just be able to just write one of them, 2x minus 3 greater than 0, and x squared minus 16 greater than 0. Okay, where did we get this? Oh, easy. This comes from, solving for one of these factors. Let me show you. Let's say we wanted to find out what is 2x minus 3 on its own. Well, we'll divide by x squared minus 16 and x squared minus 16 on all sides of the inequality. This is what I'm saying. 2x, we wanted 2x minus 3, we wanted 2x minus 3 to be alone on this side. Well, we'll divide everything here by x squared minus 16 and then divide by x squared minus 16. What you do on one side of the inequality, you do on the other side of the inequality. This and this will cancel out. You have 1 there. Then 0 divided by this will give you 0. That's how you end up with 2x minus 3 greater than 0. Then if you want x squared minus 16 to be on its own, x squared minus 16 to be on its own, then you just divide by 2x minus 3. 2x minus 3. That one cancel each other, and then 0 divided by that is 0. So our final answer is x squared minus 16 greater than 0, as you wanted. Okay, now that we know where that comes from, let's continue what we stated earlier. Stated that 2x minus 3 greater than 0 and x squared minus 16 is greater than 0. So first step is factorizing the polynomial, or whether it's a quadratic equation. In this case we have cubic equation that we are factorizing. We started factorizing it by grouping. In this case, solve for x. Okay, we want x to be on its own, so if it's minus 3 here, we add a positive 3. We add the 3 on the side of the bracket, of the inequality, and then we do the same that side. We add the 3. What we do on this side, we do on the other side. What you do on the left hand side, you do on the right hand side. Okay, so negative 3 plus 3, that becomes 0. So we are only left with 2x on this side. 0 plus 3, that the 3 remains. So in this case, what do? Well, we want x to be on its own. So we divide by 2 this side. What you do on the left hand side, you do on the right hand side. Divide by 2. 2 by 2, that leaves you with x. 2 by 2, that cancels out. Well, with 1, 1. 1 times x gives you x. Okay, it's greater than 3 over 2. 3 over 2. Okay, which is what? What is 3 over 2? 3 over 2 is the same thing as what is this? 1.5. 1.5. So x, well, I've been using the greater than sign to solve for this, to solve for the roots of the equation. However, I should have used the equal sign because I was factorizing and I was finding the roots of the equation. So that's still okay. So I'll just change the sign to an equal sign here. So this tells me that 3 over 2, which is the same thing as 1.5, is one of the root of our given equation. All right. And secondly, what's next? Well, we solve this other one as well. So we'll say x squared minus 16 is equals to 0. So x squared minus 16 plus 16 equals to 0 plus 16. Then this one comes 0, x squared equals to 16. So to get rid of x squared here, we just square root this, and then if we square root one side, we also square root the other side. So what this tells us is that the square root sign cancels out with the square, and then x is left on its own. Then we'll be like, okay, x is equals to plus minus 4. The square root tells us that the answer is plus minus, to get two answers, plus minus 4. So the roots for our given equation, or the zeros for our given equation, which is exactly what we want, the zeros, are as follows. X is equals to minus 4, I'm writing the zeros in ascending order, and x is equals to 1.5, and x is finally equals to positive 4. Okay, so having done this, having found our zeros, now we can plot them on the number line and then be able to see how many regions is our number line divided into. So the zeros divide the number line into regions. Okay, it goes all the way to minus infinity and all the way to positive infinity. Okay, right there we'll have minus 4, then it will be followed by 1.5, and we'll have 4. So how many regions is our number line broken into? Well, we have this as our region we have from minus infinity to minus 4 as region 1, and from minus 4 to 1.5 as region 2, then from 1.5 to 4 as region 3. Are we done? No, we're not done. There's still another one. The last region, that is from Yes, you guessed it, from 4 to infinity, positive infinity. Cool. So what we need to do is find out if this region, if our condition is satisfied in any of these four regions. We have 1, 2, 3, 4. So a cubic equation normally divides our linear our number line into four regions. So let's find out in which region is our condition met. What's our condition, if you still remember? Well, condition is, let's quickly have a look. The condition is 2x cubed. In other words, that equation must be greater than 0. Okay, I'll take this. I'll take it in this form because it's the same thing. I'll take the factored form of the equation. Alright, our condition states that 2x minus 3 and x squared minus 16 must be greater than 0. 2x minus 3, x squared minus 16 must be greater than 0. 2x minus 3, x squared minus 16 must be greater than 0. 2x minus 3, x squared minus 16 must be greater than 0. That's the condition. Now we'll test out the given region. We'll test out some key points, just one point from each given region. Not the zeros, but points in the regions. So for that we need to allocate points. Okay, from -4, all the numbers going there, we can just take a random point. Let's say -5 will be a random point in that region. In this region, we can take, well, from -4, let's just take minus 1. -1 or -2, we'll just take -1. You can take any point that you want as long as it falls within the region. 1.5 and 4. Well, we can take 2. 4 to infinity, we can take 5, positive 5. Alright, so we have our points allocated. Now let's examine and see if they satisfy the condition, or if they meet the given condition. So x, in this case, x is equals to -5. So 2 multiplied by -5, -3 multiplied by -5 to the power 2 minus 16 should be greater than 0. Question is it greater than 0? Well, let's find out. 2 multiplied by -5, that's -10, multiplied by, -3, and then -5 squared, that is 25, minus 16 greater than 0. So -10 minus 3, that gives us -13. Alright, so -13. -13 multiplied by 25 minus 16. What's our answer? Well, just do it here. 25 minus 16. Alright, carry a 1 to there. That becomes 15. 15 minus 6. Alright, 15 minus 6, that gives us 9. 1 minus 1, that is 0. So that is 9. And everything that side must be greater than 0. But looking at this, We have negative 13 multiplied by 9, that will give us a negative number. Let's work it out. Minus 13 multiplied by 9. 9 times 3, well, that is 9 times 3, 9 plus 9, that's 18. 18 plus 9, 27. Just check that. 9, 9, 9. 18 plus 9. 9 plus 8, that is 17. 17, 1 plus 1, that is 2, so 27. Okay. What happened? Shouldn't have erased that. Okay, 9 times 3, that's 27. Write down a 7, carry a 2. 9 times 1, that is 9, plus 2, 9, 10, 11. So minus 117 is our answer. And that definitely is not. This is not greater than 0. This is less than 0. A negative number is less than 0. I don't know why I picked negative 1 here. I could have just picked 0, because it also falls in this region. So this region does not meet the condition. Let's try the next one. We move on. From minus 4 to 1.5. I'll take 0 because it's easier to work with. 2 minus 0, that will be 0, so just have minus 3 multiplied by 0 squared, now just have minus 16. Should be greater than 0. Okay. Negative and a negative, that gives me positive number, so that tells me this is definitely greater than 0. So we'll have 316 multiplied by 3. Okay. 3/16 in other words. So let's just 48, that's the answer. Because 16 plus 16 plus 16. 16 plus 16, 32 plus 16, this one, that gives me 48 is our answer. Okay. So negative and negative, we have positive 48 is our answer. Cool. There we have the first region in which the condition is satisfied. So from that region to the second region, the condition is satisfied. Very good. Okay. Now let's look at the third region. We decided to take 2 as x. So x in this region is equals to 2. Alright, so let's see what happens. 2 multiplied by 2 minus 3. 2 squared minus 16. Everything must be greater than 0. So this becomes 4 minus 3. 4 minus 16 must be greater than 0. Looking at this, we have 4 minus 3, that is 1 in that region, in this bracket. Then we have 4 minus 16, and this is where we have problems. Why? Because we have a negative 12 here. And negative 12 is not 1 multiplied by negative 12 gives me negative 12, which is less than 0, so condition is not met in this region. So we move on to the fourth region. Maybe we'll get better luck here. Okay, so in this region, x is equal to 5. Alright, let's do this. So 2 multiplied by 5 minus 3 multiplied by 5 squared minus 16 should be greater than 0. 2 by 5, that's 10, 10 minus 3, 5 squared, that's 25 minus 16, this should be greater than 0. Alright, 10 minus 3, that is 7, multiplied by 25 minus 16, that is 9, and definitely this is greater than 0. So we have 7 times 9. 7 times 9, what does that give us? 7 times 9. 7 times 9. Okay, 7 times 7. 7 times 8. 7 times, oh, sorry. 7 times 7, that is 49. 7 times 8 plus 7 plus 7, yeah. 49 plus 7. Okay, 9 plus 7, that just takes us to 16. 6 carry 1, 56. 56 plus 9 plus 7, sorry. 56 plus 7. Okay, 7 plus 6, that is 13, carry 1, 63. So that's 63. 63. Excuse me. So 7 times 9 is equivalent to 63. Cool. I hope you tried that out and then you got the same answer. If not, just please try it again, okay? Cool. So the condition is met also in the fourth region. 63 is definitely greater than 0. Now we need to write our domain, because this region met the condition. So our domain is, what is our domain? Domain is, okay, we have second region. The solution is only in the second and fourth region. So we'll have from minus 4, second region is minus 4, minus 4 to 3 over 2, which is 1.5, and that includes union meaning together with which region? The last region, which is 4 to infinity. 4 to infinity. So that's the region in which our condition is met. So 2x minus 3, x squared minus 16 is met in these regions. Alright, so now if we are to plot our sketch our number line, would say, okay, this region is not included, the zeros are not included, so it will go all the way to infinity. That's one of the solutions. any number in the region from 4 to infinity will meet the given condition, and any number also in the second region from -4, excluding -4 and +5, excluding these zeros, but all the numbers in there satisfy the condition. So when you plot, you just sketch that. Sometimes if you don't want to use that, you can use these lines with which these circles or holes. You can use holes like that. You can use a hole, the hole saying that is not included in the. But if it was included, you would use a dot, you would fill the hole saying that the 0 is included. In this case, the 0 is not included. All the zeros are not included. So that's our solution for the first one. Thank you for watching. We'll continue in the next video.